Assalamu alaikum students. Our today's topic is effect of external pressure on the rate of evaporation and boiling. In previous lesson we have studied the difference between the evaporation and boiling. Evaporation occurs at all temperature while boiling occurs at a specific temperature that depend upon the type of liquid. So rate of both evaporation and boiling are affected by the variation in the external pressure to which liquid is subjected. Rate of evaporation tend to increase by the decrease in external pressure and vice versa. So for this you must remember the relationship that is present between the evaporation rate and external pressure. So evaporation rate is inversely proportional to the external pressure. If external pressure is high, evaporation rate is low. If external pressure is low, evaporation rate will be high. For example, if liquid is an open container, most of the molecules that escape in the vapor phase will not return onto the liquid phase. Instead, they will diffuse through the atmosphere away from the container. If we increase the external pressure, then it will force these molecules to return back to the liquid surface, making the evaporation difficult. So, you must remember that rate of evaporation is inversely proportional to the external pressure. In case of boiling point is directly proportional to the atmospheric pressure or external pressure. If external pressure is high, boiling point is high. If external pressure is low, boiling point will be low. So now let's see the case of boiling. When liquid boils, bubbles are formed inside the container which then rise to the surface. At this stage, temperature of liquid remain constant. In previous lesson, we have studied the curves in which we have seen that when boiling point is reached, then there is no change in the temperature until all the liquid has been converted to the vapor phase. This temperature is called the boiling point. If you measure the boiling point of water at Karachi, it will be 100 degrees Celsius. However, if we measure boiling point at Murray, it will be 98 degrees Celsius. Why? Because we have low atmospheric pressure at Murray. So boiling point has decreased at low atmospheric pressure. Here you can see two containers. In one, we have atmospheric pressure, external pressure is 1 atmosphere, so boiling point will be lower. But when we have increased the pressure to 2 atmospheric pressure, boiling point also increased. Sublimation is the direct conversion of solid to vapor phase without melting. For example, solid carbon dioxide, which is also called dry ice, can be directly converted to gas phase, that is carbon dioxide, at room temperature without converting to liquid state. Another example of sublimation is this appearance of naphthalene balls. So naphthalene can also sublime. It exists in solid form. It can be directly converted to the gas form. So if we keep naphthalene balls that we kept in the cloth to keep the insects away, they will disappear, they will convert to gas phase. So just like evaporation, energy needed for sublimation comes from the within the substance. We don't need to provide extra energy or heat the substance from within the substance, which then absorb energy from surrounding. This energy is sufficient to overcome the attractive forces of the neighboring molecules, which then escape into the vapor phase. Next topic is deposition. So deposition is the inverse of the sublimation. The process reverse to sublimation is called deposition, where a gas change directly into solid without going into liquid state. So in this case, there is a change from gas phase to solid. For example, formation of frost in winter season is an example of deposition. Now we will study quick check questions. Question number 1. Does the change in temperature occurs during the process of evaporation? And answer is yes. Evaporation causes cooling because faster moving molecules escape from the surface of liquid. The liquid left behind has lower energy, kinetic energy, so its temperature decreases. Question number 2. Does ice sublimes? Yes, ice can sublime, although it does slowly occur ordinary conditions. That's why snow and ice can disappear even when temperature remains below 0 degrees Celsius. Question number 3. Give one example each for sublimation and deposition other than mentioned in the text. For sublimation, iodine crystals produce purple iodine vapors when heated, and for deposition, snowflakes form in clouds when water vapors deposits into ice crystals. Another example, ice crystals inside a freezer. They can also deposit on the walls of the freezer. Applications of sublimation. Number 1 is solid air freshener. So solid air freshener can be converted directly to vapor phase, and uh, we are using it at home. For example, here you can see an image of the solid air freshener. So the process of sublimation is used in the working of air freshener. Solid air freshener contains scented substance which may evaporate with or without heating. Scented substance undergoes sublimation and disperse scented vapors throughout the room and mask unpleasant odors. When solid air freshener is exposed to atmosphere or heated in air, its solid particles gain enough energy to overcome the attractive forces that are holding them together in solid state. These particles then spread in the nearby atmosphere in the form of sweet smelling vapors. Second application is the sublimation printing, which is being used nowadays. Let's see. When the process of sublimation is used to print a design onto a material or fabric, it is called sublimation printing. Essentially, the process involves printing that transfer design into fabric using ink and heat. In sublimation printing, first step is to print a design on a special paper using sublimation ink. Specific type of ink is used on a special paper. The printed paper is then placed onto a fabric and heat and pressure are applied. So there are two things which are necessary. One is heat and other is pressure. The inks used are converted into vapors. The printing is permanent, which does not fade away with time because the ink is embedded in the fabric rather than simply attaching with the top of fabric in the normal printing. The heat supplied during this process opens up pores that are present in fabric. The ink enters in these pores under applied pressure, cool down, and returns to the solid form. So again this ink convert to solid form after printing on the on the fabric. The method is popular for print on demand t-shirts and is also available on ceramic, wood, and metal that have a special coating on to receive the ink which are in this video you can observe the sublimation printing that is being done on a shirt.